At 8:42 local time, everything still looked normal. The aircraft was cruising steadily at flight level 350. Autopilot engaged, engines stable, cabin calm. 37 seconds later, that normalcy was gone forever. This is the story of Air India Flight 171. A routine commercial flight, clear weather, experienced crew. No prior technical warnings. And yet, within minutes, the aircraft was descending in a way that no pilot ever trains for. The final radio transmission did not contain panic. It contained confusion. Stand by. We are experiencing unusual response. That was the last coherent sentence recorded from the cockpit. No mayday, no declared emergency code, no structured distress call, just a break in rhythm, a pause, and then silence. Primary radar showed a subtle deviation first, a minor heading correction, then an abrupt pitch change. At 8:44, the descent rate exceeded 2,000 feet per minute. Not catastrophic, not yet. But it was not commanded. According to flight data records, both engines were producing thrust. There was no flameout, no sudden loss of power. The aircraft was flying, but it was no longer under full control. Passengers likely felt only a brief shift at first, a light drop in the stomach, a subtle banking motion, nothing that would immediately trigger panic. Inside the cockpit, however, alarms began stacking. Master caution, flight control disagreement, stabilizer trim anomaly. The captain asked for confirmation. The first officer repeated the reading twice. The trim was moving, but neither pilot was commanding it. Modern aircraft are layered with redundancies, triple-checked systems, independent channels. For a control surface to move without input is rare. For it to continue moving is alarming. Within 22 seconds, the aircraft pitched further nose down. The autopilot disengaged automatically. That sound is unmistakable in a cockpit. A sharp disconnect tone. From that moment forward, it was manual flight. The control column inputs increased sharply, pull force intensified, but the stabilizer continued trimming forward. This is where investigators later paused the data frame by frame. Because the question was immediate. Was this mechanical failure or something else? At 8:45, the descent rate exceeded 5,000 feet per minute. Ground proximity warnings activated. Pull up, pull up. The recording captured heavy breathing, then a strained command. Cut trim, cut trim. Seconds later, the data stream fractured. Radar lost altitude coherence. Transponder signal flickered. Impact occurred at high velocity. 211 lives ended in less than 4 minutes. Official statements initially referenced possible pilot disorientation. But the flight data did not show spatial confusion. The horizon was clear, weather was stable, and both pilots were current on training. So why did the trim system move? Why did it not respond immediately to override? And why, according to maintenance logs, had that same aircraft recorded a minor stabilizer advisory just weeks before? That detail did not appear in the first public briefing. It surfaced later, quietly, and by then, speculation had already begun. Was this a catastrophic systems failure, or did someone somewhere know more than they were saying? Because in aviation, accidents leave patterns, and Flight 171 left anomalies. The wreckage pattern told its own story. The debris field was compact, high-energy impact, steep angle of descent. That immediately ruled out a slow glide scenario. Investigators recovered both black boxes within 48 hours. The flight data recorder was heavily damaged, but readable. Frame by frame, the final 4 minutes were reconstructed. Engine parameters remained within normal operating limits. N1 stable, fuel flow steady, no compressor stall. There was no evidence of dual engine failure. Hydraulic systems showed pressure in all primary circuits. No catastrophic loss. Flight control surfaces responded initially. Elevators moved with pilot input. Rudder neutral, but the horizontal stabilizer told a different story. It began trimming nose down at a rate inconsistent with pilot command. In normal operation, trim inputs are deliberate, measured, predictable. Here, the movement appeared continuous. The captain applied counter trim. The data shows opposite input. For a moment, the stabilizer paused. Then it resumed forward travel. This detail became central to the investigation, because continuous trim without command suggests one of 3 possibilities: electrical runaway, mechanical jam, or external interference within the control logic. The aircraft type had experienced trim anomalies in past years. Most were isolated, most corrected quickly, but in rare cases, faulty angle of attack data can mislead automation. Investigators examined sensor inputs. Left and right AOA readings showed minor disagreement. Not extreme, but present. Was that enough to trigger automatic stabilizer correction? The software logs suggested partial activation of a protective mode, yet that mode should disengage with manual override. Here, override force was applied, but stabilizer position continued trending nose down. That raised another question. Was the system receiving conflicting commands internally? Cockpit audio revealed rising stress. Trim cutout. Still moving. One of the pilots pulled the trim cutout switches. In theory, that isolates electric trim entirely. After that point, only manual trim wheel should function. But the descent rate did not immediately stabilize. Investigators calculated control forces at that airspeed. At 5,000 feet per minute descent, aerodynamic loads become severe. If the stabilizer is fully nose down, recovery window narrows rapidly. The crew had seconds. Maintenance records showed a prior advisory related to stabilizer motor calibration, cleared as non-critical, deferred under standard procedure. That entry was initially omitted from early public summaries. Later, it was acknowledged. Quietly. No explosive residue was found in preliminary debris analysis. No signs of onboard fire before impact. Data pointed to control authority loss, but not total system collapse. The aircraft was structurally intact until it met the ground. So investigators faced a narrowing corridor of explanation, either a rare cascade of technical faults aligned perfectly, or something altered the control chain deliberately, and that possibility moved the inquiry beyond engineering. By the third week, the public explanation was nearly complete. Runaway stabilizer trim, delayed corrective response, loss of pitch control, a technical cascade, nothing more. That was the official direction. But investigators kept returning to one detail. The trim signal was not perfectly clean. Flight control computers operate in hierarchy. One dominant command, clear priority. On Flight 171, data showed overlapping micro-inputs, milliseconds apart, layered. Some called it electrical noise, others disagreed, because the timing was structured. Not random, not corrupted. Structured signals raise uncomfortable questions. The avionics bay was inspected for tampering. No physical breach, no foreign components. Cyber intrusion was examined. Commercial aircraft are isolated systems in flight. External takeover is highly improbable. Audit logs showed no unauthorized software change, no malicious upload. Attention returned to the cockpit. The voice recorder captured strain, but not intent. The captain pulled against the dive. The first officer confirmed trim cutout. Control forces increased sharply. That matters. An intentional act does not look like sustained recovery effort. Data shows they fought the aircraft, which narrows the field again. Mechanical malfunction remains the strongest explanation. Specifically, a stabilizer control anomaly triggered by minor sensor disagreement. Angle of attack readings showed slight variance, enough to engage automated correction logic. That logic should have disengaged under manual override. It did not respond fast enough. At high speed, aerodynamic loads intensify rapidly. Even a few degrees of forward stabilizer trim can overpower elevator authority. Recovery requires altitude. Flight 171 had seconds. Maintenance records showed a prior stabilizer advisory weeks earlier. Cleared as non-critical, deferred under procedure. That detail was absent from early public briefings. Later acknowledged, the omission fueled speculation. The final report concluded, probable cause, uncommanded stabilizer trim movement resulting in loss of pitch control. Behind that clinical wording are 211 lives, families expecting arrival, crew following procedure. Flight 171 was not brought down by malice. It was brought down by a failure within layers designed to prevent exactly this. Modern aviation depends on redundancy. But when small deviations align, even the strongest systems can break.